In this video, we're going to talk about how to create an amortization table. An amortization table is a very useful tool. It can be created very easily in Google Sheets. This particular table is designed to where you can evaluate a loan. You can determine what your monthly payments on a loan are, what your total interest is going to be, how much interest per payment you're paying, and being able to figure out how much your total payments, how much this loan actually cost you. So what we're going to do is we're going to develop an amortization table, or two different tables today. The first one is going to be dealing with, say, a yearly loan amount of $100,000. Say you went out and bought a piece of property for $100,000. It's a yearly loan for 5 years with an interest rate of 3.5%. The next loan we're going to do is say that we want to go and buy a F-250 XLT crew cab diesel truck, and you get one of the lower quality ones, and you get a loan amount of that much over 5 years with 4.9% interest and his monthly payment. So whenever you go to create an amortization table, like you're going to have to for this week's assignment, you need to set it up like this. Set it up to where you have interest rate and then a set value for an interest rate. You have the years or the term right there. The loan amount is written right there. Often this says years, or you can say terms. Terms is dealing with how many times are you paying for this, or how many payments are you going to have to make. So then whenever you go up and you actually create your amortization table, you have 1, 2, 3, 4, 5, 6 different columns. You have your term, your beginning balance, your payment, your interest, your principal payment, and your ending balance. So what I'm going to go through next is how you actually fill out this table. So term is how many payments are you going to make? Well, this payment is on a yearly basis over 5 years. So you're going to make one payment per year for 5 years. So what you do is you say, you come in here and you write out how many times you're going to make a payment. So we have 1, 2, and then you can highlight these and say 3, 4, 5. We're going to be making 5 payments on this loan. So what is the beginning balance? The beginning balance is equal to the loan amount. So you just say equals, and remember we always want a cell reference. So you can say equals B4, there's your beginning balance. Now, how do you calculate a payment in, say, Google Sheets? Well, there's actually a formula to calculate payments in Google Sheets. And to find this formula, you say equals PMT, or payment. And as we can see right here, its payment is periodic payment for an annuity investment. So you say open parenthesis. Now it tells you what to put in. So what is the rate, the number of periods, and the present value. Now the interest rate that we have here is 3.5% APR, or annual percentage rate. And because these are annual payments, we really don't have to manipulate this interest rate any. So what you do is you just come in here, you say interest rate, comma, the number of periods. Well, how many times are you going to have to pay on this loan? You're going to have to pay on it for 5 years, one time per year. And then present value. Well, what is the present value? Present value is equal to the loan amount. So you can press the loan amount, close parenthesis, and it spits out a negative number where your payment is actually negative. We know this isn't actually true. So in order to make the payment positive, in front of the present value, you insert a minus sign to where it's actually the negative present value. And now you have a payment each year. This is the amount that you're going to pay per year, a payment of $22,148.14. Now if we were to drag this down, because the payment's going to stay the same across all 5 years, we start throwing off really weird values and number signs. So what you actually have to do is, because all of these cells are reference cells, or we're referencing those cells, you actually have to lock them in. So we have the interest rate. The interest rate is not changing across any of the years, and we're using one cell. So you come in here and you press F4 to lock that interest rate in. The number of periods is the same way, so you have to lock that in. as well as the present value of the loan. It's going to remain the same, so you'll go ahead and lock in that cell as well. So now with all of these locked in, they're absoluted, they're not going to move, we can actually drag these down now to where we have the same payment across all 5 years. And if we look right there, the same cells are being referenced across all 5 years of these payments. Now, what is the interest? How do you calculate the interest on a particular loan? Well, what you do is you come in here and you say equals, what is the beginning balance? What is the balance at the beginning of the year? And you multiply that times the interest rate. Now, the interest rate is not moving, as we have said before, so you have to lock in that cell. That interest rate stays the same across all 5 years. So we lock in that cell, and we figure out that in the first year, at a 3.5% interest, we're going to be paying $3,500 in interest off of this $100,000 loan in that first year. So we're paying $22,148 on the payment. $3,500 of that is interest. The remaining of that is the actual payment that you pay on the principal. So this is the loan amount. This is the principal of the loan, this $100,000. You paid this much on the payment minus this much in interest, to where your actual loan balance has only decreased by $18,648, to where your ending balance is actually equal to the beginning balance minus the principal payment, to where your ending balance is only $81,000. So the next year, the beginning balance is equal to the ending balance of the previous year. So we come right here, we say B8 actually equals F7 because that's what it ended up being last year. The interest, we can drag that one down. Principal payment, we find that the payment is actually going to be, the principal payment is actually going to be more than the previous years, simply because we're paying less interest now. Then we can come right here and say the ending balance. Now what's real handy is after you get this second line of the amortization table completed, you can actually drag these cells all the way down and we come up with the full amortization table. One way to always check to see if you made this amortization table correctly is at the end of the terms, at the end of, say, the note, if this reads 0, then you completed your amortization table correctly. And that's really how you create an amortization table on a yearly payment. That's going to be a really critical aspect whenever you're creating these amortization tables, is how many times a year are you making these payments? Are you making them yearly? Are you making them monthly? Are you going to make them quarterly, biannually, every 2 years, every other year, or every half a year, every 6 months? Are you making this payment? That's going to be a critical factor in determining how you set up these tables. And I'm about to show you why that becomes a critical factor. So if we turn our attention to the monthly amortization loan that we're about to complete, we see that there are 5 years, but we're paying monthly. So because we're paying monthly, we're paying 12 times per year. So we actually have 5 years, we're paying 12 times per year, so you actually have 60 terms, which is simply 12 times 5. This is the number of payments that you're actually going to make. So you put those first two, you drag these on down. We see we get to 59, make it a full 60 terms. We scroll all the way back up to the top. Beginning balance, what is beginning balance? It's equal to that loan amount that we find right there. We're going to calculate the payment. So we say equals PMT. Now rate. So we said that this interest rate right here, this 4.9%, is the annual percentage rate. But because we're paying 12 times a year, this rate is actually compounded 12 times a year. And because it's compounded 12 times a year, this is the annual percentage rate, but you actually have a monthly percentage rate. So in order to figure out the monthly percentage rate, you say, you actually take the rate and you divide it by 12. Now don't forget, we need to lock in our interest rates, otherwise it will not carry down as we format the payments. So the number of periods, this is the number of terms. How many times are we going to be paying on this particular note? So we said we had 5 years, but we multiply that by 12 because this is the number of payments that we're actually going to be making. Don't forget, we need to lock in the I3, lock in that cell in order to ensure that the payment stays the same all the way down. Now the future value, or the present value, sorry, we need to again make sure that we put that negative sign in there, enter in the loan amount, and remember we need to lock in this loan amount because that cell is being referenced all the way down that column and staying the same. So it's very important to remember on this payment that the interest rate is actually divided by the number of payments per year, and the number of years is actually going to be multiplied by the number of payments per year. This gets us down to the percentage that is being compounded. Now, if we were doing a quarterly payment to where we're paying 4 times a year, this would no longer be 12. This would actually be 4, as well as this would be 4. This is the amount that we pay per year, or the amount of times we pay per year in these two values. So we press enter, and we see that we have a payment of $1,065.99. So we have to come over here, we calculate our interest to where we have beginning balance times this interest rate. We're going to lock in that cell, and we're actually going to put parentheses around this just to, it'll work either way, but just to give it a little bit more of a clarification. But we have to divide this interest rate by the number of months, again, just as we did in the payment. So we have the interest is interest divided by 12, or divided by the number of payments, times the beginning balance. We figured out that on this particular truck, $231 was accumulated in interest in that first month. So we say the principal payment, again, is equal to this payment minus the interest. And the ending balance is going to be equal to the beginning balance minus this principal payment. To where we see that after that first year, we paid over $1,000, but yet we have less than only less than $1,000, actually $834 was paid on the principal. So we say equals the ending balance. The payment, we can drag it down because everything is cell referenced. Interest, we can drag that down. The principal payment is dragged down, and the ending balance is all dragged down. So what we do is we highlight these, and we can drag it all the way down to the bottom. And we see that we have done it right by finding a 0 down here. The next thing I want to show you is how do you calculate off of both one of these loans the total interest and the total payment. So total interest is the amount of interest, the sum of the interest that you're going to be paying throughout the course of this loan. So we say equals sum, because all we're doing is adding up the amount of interest that is paid on this loan throughout the whole loan. So we take these numbers, because this is the interest that we're paying per month, close parenthesis, you press enter, and we see that we paid an additional $7,334 in interest on this particular loan. So we say, well, what was the total payments? Well, the total payments is going to be equal to the loan amount plus the interest. Or you can actually come in here and you say sum, find the payment value, highlight it all the way down, close parenthesis, and we see that the total payments was $63,959.48. That is over what the original loan amount was, correct? Well, that's because of the interest. So we come over here, we say equals the loan amount plus the interest. We see that these two numbers are actually going to be the same. We can also say equals the payment times the number of times you paid. It all gives the same answer. So for this homework, you're going to have to find the total interest and the total payments, as well as be able to create these amortization charts. Something really handy about these charts is after they're made, you can come in here and change one thing, and it changes everything. So that, say this is 5 years, this is 5.9.